Okay, so the point of getting together right now is I wanted to share some information about the automation broker and APBs, and then also sort of have a Q&A. If there's any questions we can answer. The goal right now is to go over a high-level understanding of the automation broker and APBs. So if there's any kind of confusion, I can kind of clear that up. As we're going through, of course, if there's questions, please stop me, and then we can discuss anything that you want to. So with that, let me start sharing this. And assuming, is everyone able to see the screen?
No, I can't see it. Try resharing it. Looks good.
Cool.
Yes.
All right. Okay, so my name is John Matthews. I'm the technical lead for the automation broker. This is kind of a high-level description of what I wanted to cover today. So I wanted to start out and give you some background info on just kind of refresh what the service catalog is, what brokers are, specifically what the automation broker is doing, and we'll walk through the workflow of that. After we get that out of the way, I'll walk through what's involved to create an APB, and also discuss some of the environments that we have to make it a little bit easier for deploying the broker and to try out APBs. And then at the end, I have several links that can point you to other places so we can dig in deeper and get more information. So to start off, the service catalog is the new component that went into OpenShift 3.6. This is an upstream project. It's in Kubernetes Incubator. Red Hat is leading the work on this. Paul Morey is the Red Hatter that's in charge of this community effort. Think of the service catalog as kind of a way that decouples the ability to provision services and request services from actual the implementation of that logic. So the service catalog is the focal point, and it's responsible for handling all these requests of, I want to request a service, I want to bind to a service to consume it, things like that. So users would interact with the service catalog. In this case, this is a picture of the web UI. So this would be the web console for the service catalog. And the service catalog manages this infrastructure in a generic way, and then it plugs into a number of brokers. And the brokers are actually the ones that are responsible for doing the backend logic. So you'll have a service consumer that will talk to the service catalog. And then the service catalog will talk to multiple brokers. And the brokers are the ones that are responsible for doing whatever the orchestration is to get your service actually launched. So if you look at the OpenShift case, we'll have the service catalog and we'll have a number of brokers. All these brokers talk a specific API, and that API is the Open Service Broker API. So all these brokers will implement the same API. The service catalog just knows it talks to this generic API, and then it gets some information back from it. The brokers that we have right now in OpenShift, we have a template broker, there's the Ansible broker, there's an AWS broker, and there's also a middleware broker, plus a number of other new brokers that are being created. So the point of the service catalog is that it can talk to many different kinds of brokers. In the past, people used to implement a broker per service. So if they wanted MySQL, they might write a MySQL broker, or same thing for Postgres and things like that. A broker would be highly specialized to handle that service. Something that we've done that's a little bit new for the Ansible broker, and same for the template broker, they're more of a generic kind of broker. So it's a broker that has another layer that can have these basically content that plugs in that would manage the service. For our Ansible broker, we're managing those services with Ansible. So if we look at the Open Service Broker API, this is the contract between the service catalog and the brokers. The important thing to look at here are these methods. So these are the methods that the broker will define. The broker has a catalog method that just returns back the number of service offerings. The things I really wanted to highlight would be these methods like provision and deprovision. That's essentially install and uninstall. And then the bind and unbind. This is where on the bind, that's how we would obtain credentials. So say that we provisioned a database and we wanted to get the username and password. Bind is the operation that would actually create a new user for you and return the username and password. Unbind would back that out and it would revoke the credentials. So if we look at this API and we see that there's these common methods, the provision, deprovision, bind, unbind. What we've done with Ansible Broker or Automation Broker is that we've taken this logic right here and we've kind of decoupled it from the broker. So instead of having a broker where the logic is hard-coded inside the broker for the services, we've decoupled that so the APB, which I'll go into, but essentially this other component is actually responsible for implementing the logic of these operations. So by doing that, what happens is that you get this generic broker that handles all the interaction with Open Source Broker API and the catalog, and then you can just focus on whatever the logic is for your service in this APB. You'll see in the slides, and also as I mentioned stuff, I might interchangeably use the words Automation Broker and OpenShift Ansible Broker. The downstream project is currently, or the product is OpenShift Ansible Broker. So that's the downstream name. Recently, we've put more of a focus on doing upstream work, and upstream work is Automation Broker. The same code base right now. The difference in thought is that while we started this purely with Ansible, and Ansible is what we are embracing, we did recognize that the community might want to pursue other things, where they could reuse the same code we have for the broker, but maybe they want to have their service bundles that are written in Puppet, or maybe they want to use CloudFormation more, or Bash or Python or whatever. The contract that we have is pretty lightweight, so it's easy enough for somebody to swap out Ansible and use something else that they wanted to. We are going to continue to use Ansible for the ways that we orchestrate things, but for upstream, we do have enough of the code in place where somebody else could add other changes if they wanted to. So there's two main things that are happening in our project. There's the broker code itself, and the broker code will implement the Open Service Broker API, and it will handle all of the integration with the service catalog. So this is the piece that will be able to launch things, respond to requests, everything like that. Then the other piece, essentially content. And these would be what we call Ansible Playbook Bundles. You can kind of think of this similar to an analogy of Yum or DNF, where the broker could be more like Yum or DNF process, and the APBs could be more like RPMs. Like that's essentially what the APB is trying to express. It's trying to express how do I deploy this service, and deploying that may be deploying it to your cluster, or it could just be how do I run some code and deploy something off cluster, like the case for AWS or OpenStack or anything else like that. An APB, it's a lightweight contract between the broker and the APB. This lightweight contract, it is essentially just an image that we know we can execute, and we know that if we pass in the names of methods that correspond to the Open Service Broker API, some work will happen. And that's about the extent of what the contract really is with the APB. It's this image that you can run, and we're able to pass some parameters to it. And we know that some work will happen. There's also some other metadata around this, where we need to get information to get back to the service catalog that describes the APB. So we would do things like, what's the name of the APB? What are the plans, and what are the parameters? So that information will make up the APB. It will be an image that you can execute that will do some work, and then it has some metadata around it. Now, this image that we execute, it does have an embedded Ansible runtime in it. So this is an image where if you kick it off and run, it will have a base of rel, then it will have Ansible in there, and it will have the code for the Ansible logic that we want to run. So it would have a series of, in this case, name playbooks that would correspond to the methods of the Open Service Broker API. So you'd have a provision.yaml, a deprovision, a bind, and unbind, so forth. So for an APB developer, they're going to be focused more on building APB, and they're going to express the methods that they want to provide as name playbooks. So they would have a provision that would kick things off, deprovision that would uninstall, and then bind and unbind. This is a diagram that we can use to try to describe what the workflow would be. So if we think, or we start here on the left, we have a service consumer. And again, a service consumer, all of their interaction right now is through the service catalog. They could use the CLI just to go directly to the service catalog and describe objects, or they can use the web console, which would then go to the service catalog. The service consumer for right now will not directly go to the broker. It's only going to the service catalog. So then the service catalog is responsible for talking to multiple brokers. The automation broker is just one of them, but there can be other brokers as well. This communication between service catalog to broker, that is governed by this API, Open Service Broker API. And again, these are the methods that are in there. And the ones that we really care about a lot right now are provision and deprovision and bind and unbind. So the workflow here is that the service catalog will talk to the broker and will tell the broker that it wants it to essentially do a catalog operation. Where the service catalog is asking the broker, what are the services that you are publishing? The broker will discover those services dynamically. So the broker will be configured to talk to, it could be multiple different image registries. And from talking to those registries, it will discover of the images that are published, which of those images have a label that corresponds to an APB. So in the case of this picture, we're talking to the downstream registries that back the Red Hat Container Catalog. And from that, we'll get a list of APBs. Right now, we have, I think it's about 4, maybe 5 APBs published in downstream. So if we were running this with OpenShift 3.6 or 3.7, and we were talking to downstream, then we would discover that there are about 4 or 5 APBs that are present. If we were doing this against upstream, then we'd see a number more, maybe about, say, 10 or so right now. So the flow here is that the service catalog tells the broker, I want you to give me a list of the images that you know of, the APBs, and the broker will talk to the registry, it discovers and filters, and it builds this up dynamically. So this is where the content comes from. So this is another thing we're doing with the APB is we're building this into an image, and then we're publishing this image. This gets published through the normal mechanism of container images. So there's no new technology that's invented here. This is just reusing the normal way you'd build an image and the normal way that you'd push it. So we can work with, right now we're working with Docker Hub, of course, also OpenShift Registry, and some of the other registries we're looking into. Like we have some work going on with ECR. So if we go back to this now, so we have the ability to discover the APBs from the registry. If we think later, maybe the service consumer wants to provision MediaWiki. The workflow is that the consumer would tell the service catalog, I want to provision this service class of MediaWiki. The catalog will tell the broker to provision the service class of MediaWiki. The broker will grab the image or the APB that corresponds to MediaWiki. In this case, it's grabbing the APB. It's not grabbing the actual MediaWiki image itself application. It's grabbing just the APB. It runs the APB and it passes in the method that it wants to run. So it would be a provision method. The APB has Ansible code that would run a provision.yaml. And the output of provision.yaml is that a number of services, routes, and other things would be created on the cluster. So the mechanism here is that the APB will be spun up by the broker. And the APB will execute a playbook, and the playbook corresponds to one of these methods. That's really the heart of this that you want to understand from this picture, is that the broker can discover APBs that are published dynamically, and then the broker will spin up an APB image, and it will pass some parameters. And then one of those parameters would be the method to kick off, which corresponds to a playbook. And I'd like to pause for a moment here just to ask if there are any questions so we can make this a little bit clearer.
So the list of the APBs that's being communicated back to the OpenShift service catalog through the catalog API. So is it dynamic?
It is dynamic, and yes. So the broker our broker has an operation where it would bootstrap itself, and then periodically the broker will talk to the image registry, and it will refresh the service classes it knows about. So that information, that state stays in the broker until the catalog comes in and calls this catalog operation on the broker. And then once the service catalog calls a catalog operation, we'll return back the service classes that we know about. And that happens periodically. I'm not sure now exactly when. I think it might be on maybe a 10-minute interval, but it is periodic. The service catalog will ask the broker, give me an updated list of the service classes you know about.
Okay. I have a question, please. What is exactly a service class? What is a service class?
Sure. Yep.
Okay.
So service class. So this the service catalog has a number of entities that it introduced to OpenShift or Kubernetes. And one of these entities that they introduced is called a cluster service class. That's the term that is being used right now in Kubernetes. And this term cluster service class, that describes, you can think of it as an offering that the service catalog knows about. So let me see if I can show you a quick little thing, give you a little more context. So right now I'm taking a look at an OpenShift instance that I have up here. And I'm looking at the service catalog. Well, this is the web console showing it. You'll see this number of offerings that are coming up here. And some of these are APBs, like say this Hello World APB. These instances that I'm looking at, they correspond to a service class. So each one of these would be a cluster service class that the service catalog knows about. So say that somebody wanted to deploy ManageIQ. There is a cluster service class that describes ManageIQ, and that's like a top-level entity. Inside of that, there will be information about parameters. There will also be information about possible different permutations you could run of that offering. So say that we had a database, and the database we want some version to be cheaper, where we don't want to use persistent storage. And then we want another version that costs more money that would use persistent storage. We could have that same information on, say, Postgres, where Postgres could be deployed in a cheap manner for developers with no persistent storage. Or there could be one that is persistent storage. It could be one that has based on SSD and it has a lot of compute power to it. You have this ability to do all these levels of plans. We have like a bronze, silver, and gold. All that information is in this common entity, which is called the cluster service class. And right now, there's a one-to-one mapping where an APB would be mapped to a cluster service class. And the cluster service class shows up in the web console like this is one of these entries.
And the different permutations can be declared in the APB?
Exactly, yep. In the APB, we'll have metadata, and I'll go through and I can show you how some of that would look, but we could declare it, and it would be declared as a plan. Just a quick thing to show you. I'm looking at, this is metadata for an APB right now, and I'm looking at plans. And under the plans, this would be the different permutations. Like this one is using a default, but I could have other entries in here where I could have like a bronze, silver, and gold.
Okay, thanks.
Go back to this.
I also put a link in the Blue Jeans chat for the cluster service class for KubeVirt. I'll throw also in there like a service instance template for KubeVirt just as an example too.
Thanks, Ryan.
Sure.
Okay, so
I have a question.
Sure.
What will happen? For example, what will happen when, for example, the provision method will fail in the middle? Is there any possibility to do the rollback or something like this?
There is potential for it. We have not explored enough of that right now. So there are things on our roadmap where we want to handle more cases of, first of all, we want to handle getting a better grasp on error handling. We could do a better job in it right now. So there's some things there that we have seen edge cases that we don't respond as well to, we want to fix. But the general flow that we would like to have is after we provision something, we do want to have some like a verification role. And if things don't look as good as we want, then have the ability to roll back. This become more important as we do upgrades. We have the basic infrastructure. A lot of this is creating more examples to do this. We've started to create more examples that can handle complex upgrade scenarios inside the APB. We haven't done enough yet that actually explore rollback. But the basic flow of what would happen is that we would encode most of that logic inside of the APB itself. So that logic would be written for the actual service, whatever the needs are. And the APB at this point is the one that would handle doing a rollback or not.
Okay.
Any other questions? I'm going to move on then. So we just looked at the overall workflow of how things would work out between the broker, service catalog, and APBs. Now I'd like to give you a better feel of what an APB itself is. So if we think of an APB, I was calling this a lightweight contract or application definition. The APB is intended to have the orchestration logic. Anything related to the lifecycle management of the application, we can bundle it in this common component. So we can put logic here for install, uninstall, and things like that. This is not going to be the actual application code itself. So this is a container that is solely focused on orchestrating the application. So this is just the Ansible that is involved of how do I install this, how do I uninstall it. The actual application container is outside the scope of this. It would be using the same application container people use right now when they're building up their images. So there's nothing different that happens. It's just that the APB could be kind of this like sidecar thing that just handles the orchestration for whatever lifecycle management is. The APB starts out as just a directory of files. The intent of what we're doing, pretty much our overall mission is we are trying to keep this new workflow to be the absolute minimum that we can. We really want to empower people that are used to Ansible to just go about their normal Ansible business, write the logic the way you normally would with Ansible, and we just want to do a very little light wrapper around it so we can build this, we can publish it, and we can consume it on the broker side. So the workflow would really start out as just a regular directory, nothing fancy. In the directory, you would have a series of playbooks, and each playbook corresponds to one of the methods in the Open Service Broker API. That's the big contract that we're going with right now, is that the name of the playbook corresponds to the method of the Open Service Broker API. So you would have a provision.yaml, which will do the install. You'll have a deprovision that does uninstall. Then you'll have the ability to grant and revoke access, and that's through bind and unbind. There's also the ability to do an upgrade or an update, where you could upgrade from, say, Postgres 9.4 to 9.6, or you could also take an existing service and just change a parameter to it. That would be handled through the update mechanism. We've also added something that's not in the spec currently, but might be included later, which is the ability to test. So in this case, we would have the methods from the Open Service Broker API, and then we would have a unit test included as well. So this allows people that are bringing in an APB they're not that familiar with to be able to just kick off a standard test mechanism to get a sanity check if the APB is working okay. And then we also introduced this metadata file, this APB.yaml. That's the metadata file that will talk about what's the name of the APB, what are the plans that are available, and what are the parameters. When I talk about parameters, think of it that you could have a lot of Ansible logic, and you probably have it backed by some roles. And maybe in the roles, you have the ability to set 100 different variables. You could have something where you have a lot of different tweaks. You probably don't want to expose all of those to an end user. It might be a little bit overwhelming. Maybe you want to expose 5 parameters to an end user. That's the information you have in APB.yaml. So the APB.yaml would show what are the parameters that I want to expose to somebody else, and then that would generate some UI on the service catalog side. So when someone's interacting with the web console, they can say, okay, well, it turns out this APB asks me for 4 parameters. You could have information there about required parameters, optional parameters. You can even put some basic validation logic with JSON schema inside the same thing. So we have this directory of files that has the content. This is the Ansible content for actually deploying your application. We then would build this into an image. When we build it into the image, it's based off the minimal rel image, and it has an Ansible runtime inside of it. So the full APB that gets built out to use will be an image that we can execute. And when we execute the image, we pass some parameters. And the first parameter would correspond to the action that we want to invoke. And then that action gets transferred to this name playbook. So when you think of this, think of the APBs that starts out directory files. You can do your debugging and testing without building the container at all. You can just go ahead and run Ansible Playbook and then pass in a provision.yaml with the parameters you want, kick it off. So you first start to debug this just by working with Ansible from the command line in a directory. Once you're happy with that, then you would start to fill in the apb.yaml, which would describe the plan and the parameters you want to expose. And then you would build this into an image. And at that point, we'd be ready to publish this to a remote registry and then start doing a workflow with the broker and the catalog. So let me pause for a minute. Are there any questions I can answer about APBs? And I will go into an example of creating one. But before we do that, if there's anything I can clear up, be happy to.
I have a question about creating dependencies between APBs. Like if I can, like in RPMs, that I can specify in my spec file that I need another package, if I can do it in APBs.
Yep. Currently, we don't have a good answer for that. It's on a roadmap as well. So this is a lot of new work that we're building out. So we haven't had a chance yet to really flesh out how we want to handle dependencies. That is something that we will be looking into for the next release. What we'd like to be able to do is, you hit on it like completely, is exactly as the RPM model. Be able to do things where we could say that we have a requirement of another APB. Perhaps the dependencies would even go beyond APBs. We were thinking of looking how we could tie this into, say, Helm charts and other kinds of offerings the service catalog provides. We do want to add that into the story of how we can do that, where we can have requires, probably a conflicts, and get the same kind of story that you can express in RPMs, be able to express that here as well.
Okay, thank you.
I have a question about what is my role? I have a role which installs or provisions some application, and this role depends on some other roles, or not role. Playbook depends or use other roles from the Ansible Galaxy, for example. Is it possible to express this fact and that APB will download these roles as a dependency before running the playbook? Okay.
Yes. So we do have that. So for example, some of the APBs we have work with AWS and using cloud formation templates and other things. So the APB needs to install Python Bodo in order so some of the cloud modules will work correctly. So in cases like that where we have dependencies, right now we're solving that, I think, on the Docker file side, because you will see an APB has just a standard Docker file and its normal image that gets built. So we would express the dependencies on that side for building. In this sprint actually is the first sprint that we are starting to look into how we can integrate with Ansible Galaxy. We've been meeting with Chris Housecheck, and Chris and his team are starting to do back-end work. So APBs will become a first-class citizen in Galaxy. The workflow would be that eventually we could do an Ansible Galaxy init, and then that would create the skeleton for an APB. We are also looking to add in adapters to the broker. So the broker will be able to communicate with Galaxy directly, discover APBs that have been published from source, be able to execute those. And when it does the execution, it will be able to do a mechanism, probably something like a pip install of requirements.txt or something like that, where there's this mechanism to get the dependencies. Besides the Ansible role dependencies, how can we also get any other third-party libraries and things like that that are needed? So that is a story that we're actively working and fleshing out. We have some bits of it right now where you can do this yourself with a Docker file, and we should get a better story where it's more integrated with Ansible Galaxy and the dependency is a little bit more seamless. And we'll probably have that by the end of the 3.10 release.
Okay, thank you.
I have a question. So as I see these action playbooks which are there, So if you wanted to or needed to add some custom actions, for example, for the keyword virtual machines, we will need something like reboot or something like that. Is it possible somehow?
So on the APB side, completely possible. The APB was written so we can handle that, and we had the thought of just adding these new actions in right here. So if you wanted to reboot.yaml, we can definitely package that up. That's not an issue. The problem that we will have is how do we expose that to the service catalog? So if we wanted the interaction to be purely from the service consumer, and we want that to be the place where it's just service consumer to service catalog, we don't have a mechanism right now where we can add in arbitrary actions. The Open Service Broker API itself has some work going on to add extensions and to add arbitrary actions in. So this API has ongoing community discussions to solve that problem, where we could add in a generic, say you wanted to reboot, whatever you call it, we could add that in. It's not there today, but it is something that's being discussed. If we were doing this today with something like that, we could fake it out and have direct communication to the broker, but that would also require some extra privileges and some other complications. So if there is a need that we support that, we might be able to do something where we could do this through the broker, but that's not something that we've really fleshed out at the moment. At the moment, for handling these methods from the service catalog side, it's only the ones defined by the Open Service Broker API, and the other extensions we put in at them right now, we have not been able to expose the service catalog. So really, the correct answer for this is that we need to get the extension support into Open Service Broker API. And that conversation started, let's say, 3 or 4 weeks ago in the community, that they were talking about doing that. Once they have it approved here, then we can get this into the service catalog. And then at that point, we'd have a good story where this can be done seamlessly.
Okay, thanks.
I'm going to move on. So this is just kind of a recap of some of the things with the automation broker and APBs. So when you think of the automation broker, think about this as a way that abstracts out the OSB API details. There's a lot of lower level details of writing a broker and things that you have to worry about to get this correct where it can talk to the service catalog. By going with an approach like this, you don't really need to worry about the broker. You just assume the broker's there, the broker's doing the right things, and all you have to worry about with your APB is you just worry about the name of those actions for the OSB API. And then you write your Ansible so it conforms to that. What we're calling the APB, there's a light contract with it that the broker will be able to interact with this image. And right now, we're still exploring a name for it, but the latest name is Service Bundle. This is just a lightweight container that we're able to execute, that you pass in a parameter and it knows to translate it and do some kind of work based on it. The thing that's kind of interesting with this is that while we are continuing to use Ansible for how we solve this, it is possible that people in the community, if they wanted to use, say, Bash, Java, Puppet, whatever, they could reuse our broker, because our broker does not know anything about Ansible itself. Our broker just knows I kick off this image and the image runs. So there's an ability here where what we are doing for APBs could be rewritten to use Bash or Java or whatever. And you can use the same automation broker code. It's just the image details get changed. So we're not planning to do different ones for our downstream work. We're planning to stay with Ansible. It's just kind of something here that if people did have other needs, they could explore other ways of building these images and still reuse the same broker. Another bigger thing here is that by following this kind of pattern where we break out almost something like infrastructure and content, it decouples the release cycle. So it would be no problem for KubeVirt to release whenever they want to an APB, and they can do that if they want to, say, on a weekly basis, where they could redo the APB, they could publish it to our Red Hat container catalog, and the automation broker would be able to pick that up because it's just content to bring it in. It's the same analogy as Yum, DNF, and RPMs. This does provide an advantage to enterprise setting because now you're not locked down where you have to get every single change into the broker, go through QA and everything else. You can just really QA your one APB, and that's all you have to worry about. So that concludes the background piece that I wanted to give you on the automation broker and APBs. Next, I want to spend a little bit of time to talk about what's the workflow to actually create an APB? So these are the high-level steps to create an APB. We have a Python tool, and the Python tool is called APB. You can do a pip install APB and get the latest version of this. And this tool has the ability to create a skeleton for you. It also can handle some things to update the Docker file. There's a requirement I'll go into, but the Docker file needs to have a special label on it for things to work correctly. This tool will handle that. And it also has some other things to make it a little bit easier to run an APB, to push it, build, things like that. You don't have to use this tool. So if you wanted to just do everything by hands, you're totally free to just take example playbooks, put them in the right format, create an apb.yaml Docker file, and then build them. But this tool will make it a little bit easier. So if we look at the steps, the first step is you run apb init. This generates a skeleton. And in that skeleton, you'll have the basic files, you'll have a playbook set up, and you have a role. After an author has their skeleton laid down, then the next step would be to modify the Ansible logic in there. So iterate through and modify the Ansible until you're happy with it. So this is where you'd be changing the role, the playbooks, and you'd be running them by hand from your laptop, your machine, wherever it is. So to an Ansible playbook, provision.yaml, passing the parameters. You'd iterate at this step until you're happy and you have Ansible logic that is doing what you want for your application. After you have that, then you would edit the apb.yaml, and you would expose the parameters and the plans that you want. And those plans would be essentially the different permutations of the service class. So that could be like a bronze, gold, silver. And the parameters would be the public parameters you want exposed. So as I mentioned before, you might have 100 different variables that are possible to change in your playbooks and your roles, but maybe you only want to expose 3 of them. So you'd have that there. These parameters you expose, that's what an end user will see, and that's what they'll be prompted for. We do have documentation on the apb.yaml spec. I'm not going to go into that now, but I will share this out later on with the email, and anyone can open this up and look more at details. So the steps are right now, you do an init, you get a skeleton, you edit your Ansible, so you're happy and it runs. You edit the apb.yaml, so you expose the parameters and plans. So at this point, you have most of the source together. The next thing to do is to update the Docker file. So you run this command apb.prepare, and that will update the Docker file with the labels that we need so we can run things okay with the broker side. After you do that, you build the container, and then you just push it to a registry. So these are the basic steps that you would follow as you go through. If we take a look at the APB itself, what I'm showing you now is a very high-level concept. This is not technically the way that we're doing APBs right now. This is just an easy way for the concept for you to comprehend this and sort of get and grok it, really. So a very simple way of thinking of this is that there's an apb.yaml, and in there you have the name of APB, and then you'd have some parameters that are listed out. And the parameters could have a default value in there. They can also have something about they're optional or they're required, and you can put some more details about JSON schema to get more descriptive about that. But think of apb.yaml is metadata. It exposes parameters and plans. Next, we'd look at the playbooks, and the playbooks would be responsible for executing the logic that corresponds to whatever the method is. So provision would install, deprovision would uninstall. So the thought here is that an APB author would put any of the logic they want for installing an application in provision.yaml. Really high-level concepts, you can think of it as a case where you'd almost just do a shell command of OC create. Most of our APBs do not do this anymore. It's a little bit too simplistic, but for concept-wise, you can think of it as that if you had your resource YAML definition file, then you could just do an OC create on it, and that might be a very simple APB to start getting started here. And then deprovision would just back out that change. So on the examples we have now, that might be a case where it would delete a deployment config. It's something like this, just a really crude example. We could say that it's almost like deleting a namespace. So we'd have the APB.YAML, that's your metadata. You'd have the name playbooks that corresponds to methods. Then when we actually build this as an image, we have a Docker file that will build it. And the Docker file will inherit from a base image. and then it sets up some labels. It could add in optional dependencies we need and things like that. There is one important thing that I want to call out that's a little bit different in what we're doing here. We have this very special label that is com.redhat apb.spec. This label will look a little bit confusing at first because it's a base 64 encoded value of apb.yaml. So this is a little bit strange when you first look at it because you'll see this Docker file and you'll see a lot of text in here and it's kind of weird, like wondering why we're doing that. The reason that we do this is that when we respond to the service catalog with a catalog request, we need to give all of the information that we have about the offerings that the broker discovered. So if the broker went out and discovered, say, 100 APBs, the broker needs to give that information of all those APBs to the service catalog. We, of course, can't download every single image and then crack it open and look at it. That would take too long, wouldn't really be efficient. So what we're doing is we're having the information that we need to respond to the service catalog in here. It's in this apb.yaml file. And then we are encoding that on a label. So in this case, we don't need to download the image at all. We just look at that one label on the image, and then we get enough information that we can respond to the catalog request. So if we're looking at a registry that has a very large number of APBs, we can still get all the information we need, extract it, respond to the request just by looking at the labels. So this does bring up a potential problem, is that this label needs to be the most up-to-date version of apb.yaml. So you have this potential discrepancy that if you just set the Docker file up once, never updated it again, and then you iterate it through the playbooks and apb.yaml, you could be out of sync when everything gets built. For that reason, we introduced APB tool just to help a developer to keep the workflow with this so they will be able to have their label always reflect what apb.yaml is. So as long as a developer is doing apb.prepare and they're using this tool will always look at apb.yaml, it would base 64 encode it, and then it'll update the Docker file. So an end user that's developing APB will not need to worry about this. They just run apb.prepare, and then it'll work for them. So let me just recap again on the steps. So the steps to build an APB, you run APB init, generates a skeleton, you iterate on your Ansible code. Once you're happy with that, you edit the metadata file, and you expose there your parameters and your plans. After you have that done, you do APB prepare. That will update the Docker file. And now at this point, you just build. You can build as you normally would with Docker. You can do APB.build, whatever you prefer. And then you push it to a registry. And then the broker would be able to pick it up. I'm going to pause for a minute and ask if there are any questions on this workflow.
Not so much about the workflow. I have a question about that APB YAML file, specifically about the parameters there. So how much flexibility you have in the parameters section? What I mean is that in the KubeVirt thing, we will need probably something like have a list box which contains all the templates you can use to create a virtual machine from. So can we like dynamically return something, or dynamically calculate something, or ask for from some database or somewhere and return it so it will be listed to the user, or is this just some hard-coded values in this APB YAML?
So as of today, it's hard-coded values. The hard-coded values have different kinds of parameters that can be applied to them to verify they're correct, but they're all hard-coded. We have a task for this sprint to investigate the use case you just brought up, because when it comes to KubeVirt with the VM templates, it was understood that we would need the ability to dynamically discover what's available and then populate that back to the service catalog. So that is something that we're investigating to find out what's the right way we can do that. We don't have a solution right now. I think that's something that we will be able to solve, but we just haven't spent the time yet. This is the first sprint that we're going to address that problem.
Okay, great, thanks.
Any other questions? Okay, so let me move on. So the next slide here, this just is an area that shows you examples that we have that are upstream. So we have an organization in GitHub called Ansible Playbook Bundle. In there, there's a number of different APBs that are published. I highlighted some here that might be worth looking at. The Hello World in particular is one that we are revamping. It's not quite merged yet, but we have a PR that's outstanding. As is new work, we are continuing to fix up best practices and adapt to newer methods. There are some newer Ansible modules that are being published that we are starting to consume in the Hello World. So if you look at the latest PR there, that will give you kind of a feel of what's the next version of APBs, how they're going to be structured. This is more like lower level details of how Ansible's written. The Postgres is a good example that shows you how to do multiple plans. It also shows you how to do an update. And the update's pretty cool there, where we can do things. We can upgrade from a 9.4 to a 9.6. We also have some examples here of how can we change plans to go from, say, non-persistent storage to persistent storage, but not lose data. And that really just uses some Ansible to do things where we can export an existing database, migrate it to a new one, and so forth. So you can see some a little bit more complicated examples in Postgres. MediaWiki is a good example to show how we can consume a binding. And a lot of times we'll do a demo where we consume the binding from Postgres. Another thing to mention is that Amazon Web Services has also inherited the work that we've done for Automation Broker, and they are releasing their own broker called Amazon Web Services Broker. That broker is using APBs as well. And here's a list here from AWS of about 10 published APBs that they released just a few months ago. So right now we went through the workflow, and we also went through what it is to build an APB. I wanted to share some information about how our developers would go about bringing up an environment to test things and install a broker. So there's a few different methods that people like for running OpenShift. First thing to mention is that when we started this effort, we were exclusively OpenShift focused. When we first did the work, we did not work with pure Kubernetes, only with OpenShift. We've since done more work on the Kubernetes side, but the OpenShift side right now is the one that's a little bit fleshed out, a little bit better. So you'll see that there's more solutions, we have more documentation. So the first way to go about stuff is you can do an OC cluster up. And with OC cluster up, we have this script. And this script will show how to deploy our broker. And if I just bring this up for a second. So if you look at this script, you'll see things here where we would use OC cluster up, and that brings up the OpenShift cluster. Afterwards, we're doing some extra logic. What we're doing here is really all about certs. We are just grabbing some SSL certs so we can set environment variables correctly in a template. After we do that, we're getting the template, and then we're going to just really process the template, and the template will deploy the broker for us. We have this in the script because the certs started to make this more complicated, so having the script of this, you don't really worry about it. It will just kick that off for you. So that is one way of doing this. Go back to this. Okay, so you have OC cluster up, and you can run the script, and then that script will show you how we can deploy the broker through a template. There's also an add-on that we recently added onto Minishift, and we have some documentation. We also have a YouTube video that will walk through and show you how you can use Minishift with this add-on to get the broker deployed. There's also work that we've contributed to OpenShift Ansible. So if we want to get a more focused environment that a customer would run, a customer would typically be using OpenShift Ansible to bring up OpenShift. And we have a role in OpenShift Ansible for deploying the broker. You can see here. Then we have a vagrant environment set up that everyone should have access to look at. This vagrant environment will have settings for OpenShift 3.6, 3.7, and 3.9. So it will show you examples of how you create the inventory file and what are the right settings. So you'll go through and have the broker deployed. On OpenShift Ansible, the service catalog and the broker get deployed by default. So any user from 3.7 above using OpenShift Ansible, they will have the service catalog enabled, and they will have the automation broker there. Just to call out, with OC cluster up, only the service catalog is installed by default. In OC cluster up, the automation broker needs to be installed separately. And the last thing I'll mention here is that we do have a set of Ansible scripts that the development team uses, and we call this cat ASB for catalog and Ansible Service Broker. This cat ASB repo, this is really intended to handle more of edge cases to make the developer workflow a little bit better. So there's things here that we're doing where a lot of times we'll do demos and we'll have an EC2 instance. So cat ASB will go ahead and create the EC2 instance. It will create search for us, we'll let's encrypt, it will set up authentication, then we'll run OC cluster up and configure that. It will just make sure that it deletes certain images and clean up other ones. So things like that. If you first look at a cat ASB, it's a little bit more complicated because it is handling edge cases. The simplest way to get going is OC cluster up, which will use the script. So the run latest build is pretty much the simplest way, OC cluster up and use a template to get the broker. Mini shift is another easy way to get going. And then these other ones can be a little bit more involved. Once you have cat ASB set up with the right variables you want to use, then this is a great way just to keep on doing the thing repeatable. So our development team uses this since it's a repeatable environment. So that right there is what we have that's focused on the OpenShift case. Ryan has done a lot of great work to get us closer to running on pure Kubernetes. This is something that we still are working towards. The documentation is not as fleshed out on this side, but we do have work in cat ASB where you can just pass in a -K, and then that on the local cases, this will bring up a pure Kubernetes environment for you. Now, when we're on pure Kubernetes, we do lose some functionality. Most of the functionality we lose is more on the security side. There are some APIs that aren't available in Kubernetes and available in OpenShift. So the broker would have to get configured a little bit different as well. But essentially, those are two slides that sort of show you different ways to bring up the environment. And I'll just pause for a minute. Does anyone have any questions on this? Okay, so I'll move on. So I wanted to call out some recent blog posts that I think would be very helpful for anybody that's interested in APBs and the broker. So Jesus creates this great blog post up and running. This is a good kind of starting point to see how do you use that run latest or script similar to that to get an environment up so you can interact and play with the broker. And then Dylan put this together for creating APBs. MediaWiki and Postgres are two big examples that we use, and Dylan walked through how would an APB developer go about creating these. In addition to these two blog posts, there's also a blog post that looks more at the development from an ISV or partner perspective. And Rocket Chat is a good example of a partner that put together an APB, and they're starting to work through the process of how do they get this certified and available through the downstream Red Hat Container Catalog. So if you're interested in the broker and APBs, I would really recommend read these two blog posts. I think that would do a good job for giving some more background info. And then just to sort of close up, there are several pages here, just extra links that I thought might help you if you wanted more information on certain topics. So for example, the Kubernetes Service Catalog, it's an upstream project. This is the GitHub location. Paul Morey, he's a Red Hatter. He's the one that's leading this effort, community-wide, plus of course Red Hat as well. There's just two example talks that Paul did for OpenShift Commons. If we're looking at the automation broker, we have an upstream landing page that can point you more info. That's this page right here. So if you look at that, there's some more info you can get to. In the bottom, you'll see that there's stuff here for like our YouTube, GitHub, Trello, all those blog posts, things like that. And then I also have the links listed here too. So GitHub, Trello. We have a lot of documentation in GitHub that you probably want to take a look at. And then also just some blog posts for the broker. For APBs, this is a link to the spec itself. And then just recapping again, we have examples that are upstream to look at. And then some information about the APB tool, and then more blog posts. And then this is contact info for the team. So we have a mailing list, Ansible Service Broker at redhat.com. This is a public mailing list. If you're interested in receiving announcements about future work and troubleshooting, things like that, this is a great thing to subscribe to. We are also on IRC. We're on Freenode, AS Broker. We have a Twitter account now. And then, of course, this is a link to our YouTube. And just calling out some of the people, if you have specific questions, Eric Dubé is our product manager. He's a great guy to talk to for roadmap questions, things like that. Todd Sanders is engineering director in charge of this effort. And I help Todd out with kind of on the technical lead side of things. So with that kind of sums up the information I want to share with you. We have a few more minutes if anyone has questions.
Yes. Do you recommend to create an APB per cluster type? So an APB for Kubernetes and an APB for OpenShift to create a cross-cluster APB for an application?
I truthfully don't have an answer to that right now. That's something that we're still kind of working towards and seeing what the right way to go is. Ryan Halsey is on the call. Ryan has the most knowledge right now with how we're working with OpenShift and Kubernetes. Ryan, do you have any comments on what you'd recommend at the moment?
Can you repeat the question, Gal?
Yeah, so my question is, let's say that I have an application like KubeVirt that's supposed to run also on OpenShift and also on Kubernetes. Do I need to create two different APBs in that case?
So it depends how you approach. If you come at this from the angle that you're going to do from Kubernetes first, then it will work on both. If you want to come at an angle where you want to do an OpenShift and then to Kubernetes, and you use things that are OpenShift for specific resources like routes, for example, or deployment configs, then you would need two separate playbooks. It would be, I mean, you can have, you only need one APB, but you have two separate playbooks. There's a variable that we provide into the environment of the APB it's called cluster, and you can use that to determine if you're running on OpenShift or Kubernetes. So if you want to have the separate playbooks and you want to use routes, you want to use deployment configs, anything else that's OpenShift specific, you're free to do that. Just when you do it, use that variable to determine which one you're running on, and you can go from there however you want to do it. But it's up to you. If you don't want to use OpenShift specific stuff, go right with Kubernetes. If that's sufficient, then that'll work on both.
Okay, so I guess that the Ansible modules that are provided inside the APB can be used also for Kubernetes and OpenShift for objects that are. Yes.
Like for instance, if you use Kubernetes raw as an OpenShift as a module, like that will just take whatever raw YAML that you want to run. So primarily, if you want like the OpenShift API, there are some, like I think pre 2.5 Ansible, there's some modules that specifically reference OpenShift resources. Those will be only run for OpenShift. So anything that you're aware of that is specifically for OpenShift is at the bottom, add like a when cluster equals OpenShift, and that will run when you're running on OpenShift. And if you're like doing any template stuff, like if you're any YAML, like raw YAML that you have, and you're pasting it over, and you're aware that it's going to be OpenShift specific, same thing, just add a when cluster equals OpenShift.
I understand.
I can go yeah. When we kind of merge some of the KubeVirt APB work into the KubeVirt Ansible stuff, I can point you exactly to this.
Okay, thanks.
No problem.
So I can stay on for another 2-3 minutes, then I'll have to drop for another meeting. But any other questions right now? Okay, so I'm going to assume then we're good at the moment. So thank you everyone for dialing in. Sure.
Thank you very much.
Sorry, no, was there another question?
No,
yeah,
I said thank you.
One more question.
Oh, sorry.
One more question from me, maybe. But maybe it's a difficult one. I don't know. I mean, apart from like deployment of KubeVirt, we're also pondering on the possibility of using broker API for VM provisioning. And I'm not sure whether for that task the Ansible broker actually makes sense, because the operations are not. I mean, it doesn't. They don't seem to map very well to Ansible actions. But maybe it would make sense to have a dedicated virtualization broker. I don't know. I mean, can we maybe offline discuss the reasoning or advantages of
Sure.
each to decide on which way to go?
Yeah, definitely. If you would send me an email, then we can get some time, and then definitely bring Ryan into this as well, and then we can chat on that.
Yeah, okay. Because I mean, it supposedly can be done through APB as well, but I don't know. It looks to me a bit too awkward for that.
We can talk about that and see. The way that if you do something where, say, you had some small Python examples that kicked off whatever you wanted for the VM provisioning, it would be pretty easy to convert that into something with an APB. If you have something where you have some APIs you're hitting and some logic with it, I think we could get an APB for it that wouldn't feel that awkward. If there is a good reason, though, and that's just not going to work out, and you want to pursue a broker, we are also looking into taking a lot of the lessons that we've learned and how to create a broker and feed this back into a project that would help for other new brokers to be created. Paul Morey has done some of this work too on the open service broker API side with a new project he went over at Commons just a few weeks ago, I think 2 weeks ago. That's like a first step towards it. We'd like to take a lot of the stuff that we've done for learning how to work with Kubernetes and OpenShift and feed it back into something that gives you a pretty good basis that you can just vendor in. I would say that when you create a broker, there are a lot of edge cases and things to worry about. So you just want to make sure that if you're going to go down, create another broker route, you're getting enough return on your investment for it. But we can definitely talk about that, share some of the information that we know, and try to help you make a decision.
Okay, thanks.
Cool. Okay, thanks everyone for your time. And I will follow up with an email with this recording and then links to the slides. And any questions, please reach out to us. Happy to help.
Thank you. Bye-bye.
Thanks a lot.
Thanks, everyone.
Great
Bye.
presentation. Thanks.
Thanks, bye-bye.
Bye-bye.
Thanks, folks.